Hello and welcome to Miss Ma's Advanced Functions class. This is 1.4 Transformations of Functions. So we're going to pretend that we started with some random function f of x, and that function is going to be transformed with four different things. We've got a, we've got k, we've got d, and we've got c. Inside of the brackets is horizontal, and outside of the brackets is vertical. So a and c are vertical, and k and d are horizontal. So let's talk about A and C first. The A is going to give us a stretch or compression, and if it's negative, it's also going to give us a flip, so it could give us a vertical flip. C is added on to the end of the function, so it's a shift up and down. With K, it's very similar to the A, except it's actually counterintuitive. So when you think of the inside, it is counterintuitive. It goes opposite what you think it's going to do. So if I had, for example, y equals 2f of x, this is going to be a vertical stretch by 2. But if you have y equals f of 2x, it's on the inside now, you see, it's a horizontal compression by 1/2. Some people like to say it's a horizontal stretch by 1/2 or a horizontal compression by 2. Those are fine ways of saying it. I just like to say horizontal compression by 1/2 because I think it's the easiest way to remember it. But it is counterintuitive, so you see the number is a whole number, so you think, oh, it's going to be a stretch, but nope, it's inside of the bracket, so it's actually a compression. But either way, we're going to write stretch or compression for that because it's still stretches or compresses it. And if it is negative, then it will also make a horizontal flip. So that's something good to remember. And the D, it's subtracted off, so it's going to be a shift. And again, it is opposite what you think. So if you see a +3, it's actually moving to the left instead of the right, as you might expect. Okay, so let's do some questions. Oh, before I do that, maybe I should talk about the order in which we do these transformations. The question will usually ask you what order you want it, you should be doing them in. And usually the answer is 1, 2, 3, 4. That's the easiest way to think about it. You always want to do stretches, compressions, and flips first, and then do the shifts. So just do it in this order, reading right across, left to right. That's the easiest way to do it. If you don't state them in order, then you will get it wrong, so make sure that they are in order. Here we've got y equals -2g half x plus 3 plus 4. So we've got lots of transformations, and the parent function that's given is absolute value x. So let's write the transformations in order. We've got a vertical flip, because it's a -2, so that makes it a flip. And then we've also got a stretch by 2, so a vertical stretch by 2. This half makes it a horizontal stretch by 2, so it's again counterintuitive. You think it's multiplied by half, so it should be compressed, but it's not. Then we've got +3. It's the opposite way you think, so it's going to be left 3. +3 makes you think right. And +4, now we're outside the bracket, so it is intuitive. Up 4, it's what you expect. Okay, so first of all, I'm going to draw the parent function with a line, and we learned this in 1.2. It's the absolute value function, looks like this. That's y equals absolute value x, and you always want to label your graph. Y equals absolute value x. There you go, that's the parent function. When you are drawing the functions, we do expect you to draw the parent function along with it, you know, some significant points. We've got quite a few points here. I don't want to draw a mini graph that's just like, whoop, like that's the teeniest, tiniest thing ever. So just make a nice big graph that fills in quite a bit of information, so that we know that you actually know what you're doing. We're going to do a vertical flip and the stretch together. So I like to do all the vertical flips and stretches together, the horizontal flips and stretches, and then I like to do the shifts together, because it's pretty easy to move your graph around, but the stretching is a little bit difficult to visualize. If you're a really gifted visual person, then maybe it would be easy for you, but I am not, so I'm going to go with, you know, I'm going to go with doing it in steps. Okay, so vertical flip and vertical stretch by 2. So you can see that here 0, 0, it doesn't flip, and 0 doesn't stretch. So I'm going to start with here. But then as I go to here, this is at negative 2, 2. And so 2 multiplied by negative 2 is negative 4. So it actually stretches out to negative 4 at that point. So it actually goes out to here. And here it's symmetrical. It's an even symmetry. It's what we call an even symmetry. So now that I've got those two transformations on there, I'm going to label that graph y equals negative 2 absolute value x. You just want to label it with whatever the numbers are that you added to it. That's what you're going to write into there. Alright, let's do the horizontal stretch by 2. I've already color-coded it, so I'm just going to follow that color code there. It's red. Horizontal stretch by 2. So basically, anything that I have 0, 0, it's going to, well, 0 is multiplied by 2 is 0. Here I've got negative 1, negative 2. If I multiply the x value by 2, I will get negative 2. So that is the, and we're going to leave the y values alone. So you're only worrying about the x values. So I'm going to start at 0, 0 again, and I'm going to stretch out all these to get multiplied by 2. And same on the other side. And there you've got a nice graph. I'm going to label that. Y equals negative 2 absolute value half x. And you want to get lots of colors because then that would be really convenient. If you don't have lots of colors, you can do dotted lines or something like that, but make sure that the final graph is going to be nice and obvious. Okay, so now I'm going to take all these points, I'm going to move them left 3 and up 4. So if I take this point right here, I'm going to move 1, 2, 3 over and up 4. So it starts here, and then take all the other points and move them. Whoop, that's not a line. I'll start here, and take all the other points, move them left 3 and up 4. 1, 2, 3, 4, and then you can draw your line through them. You can draw the points on there. I happen to have a software, so I'm going to just use the software to draw my lines, because my lines are kind of ugly. And draw that, and then you do the same with these lines. So 1, 2, 3 over, and 1, 2, 3, 4 up. And so we should be going through that point there with our new blue line. And this is our final transformed function. And I will label it in blue. Y equals negative 2 absolute value 1/2 x plus 3 plus 4. That is our transformed function. You can just see I'm using the function notation in place of the absolute value function here, so I'm just writing it wherever was inside the bracket here goes inside of the absolute value. Just replace g of x with absolute value x. We're going to do one more example here. So this is just a random weird function called g of x. Let's label that g of x actually, because then it'll be less confusing. Okay, so I want to take this and I'm going to do the same transformations because I'm just asking to do the same transformations. So I've got a vertical flip, I've got the vertical stretch by 2, I've got the horizontal stretch by 2, I've got the left 3 and the up 4, and hopefully this graph is going to accommodate my whole graph. Okay, so let's start with green, right? Is that right? So we're going to do a vertical flip and a vertical stretch by 2. So you can actually do this in a couple of different ways. You can do what we just did, where we do each step and then we get it all done. Or you can actually use a different formula, and you can memorize this formula if you like. That formula is, we're going to take any point on here. For example, this is negative 3, 2. So these are our x and y coordinates, and the transformed point, or the image point is what we call it, you can find it by using the following. It's x over k plus d ay plus c, and you can use that formula if you like. I hate memorizing formulas, so I try to avoid that wherever possible, but if you want to use this formula, you can. And you just replace the x with negative 3 and the y with 2, and then here we've got, this is the a equals negative 2, you can see it, k equals 1/2 D, remember the D in our original is minus D, so it's actually the negative version of whatever you've got here, so that kind of builds in the counterintuitiveness. And C is 4. If you have no idea what I'm talking about right now, that's okay. Just do what, all the different steps, and you'll do just fine. If you want to use this formula here, feel free to do that also. In this case, I think it's going to take a little bit longer to use these points, so I'm going to just redraw, by step, but you could do it with this formula as well, and that would be perfectly fine for this particular question. So I'm gonna do it with the steps, but if you do it with the formula, then you could you'll find all the points and then connect the dots in a line, because these are all lines, and then you're good to go. So just pick the major points and do it. So let's see, vertical flip and vertical stretch by 2. So here I'm looking at the y coordinate, which is 2, and I'm going to multiply it by -2, so it flips down to -2 and then stretches out to -4, so it starts here. And I'm going to go to the next point, which is the y value is -1, and I'm going to multiply by that by -2, so I actually get 2. And then you just connect the dots there. This one is at 1, and it will get multiplied by -2, so I actually go down to -2. And you can see the x coordinates are all exactly the same as they were. And here I've got 3, 0, so 0 times -2 is 0. It goes to the same point. You can see that the fixed points on this, when we do a flip, the fixed points, where the ones that stay exactly the same, are all on the x-axis. It's because we're flipping over the x-axis. Okay, and let's just label that with green. So I did -2 g of x, and then I'm going to do blue. So I'm going to take all the points on the green, and I'm going to do a horizontal stretch by 2. So this was a -3. I'm not going to worry about the y values, I'm only going to worry about the x values, and -3 times 2 is 6, so we'll go to 6. The next one has a x coordinate of 0, so 2 times 0 is 0, it goes there. This one's at 1, so it's going to be multiplied by 2, it gets to 2. And again, the y coordinates are the same because I'm only worrying about the horizontal right now. And 3 times 2 is 6, so off we go to 6. And there you go. We've got the second step done, almost done. This is -2 g of 1/2 x. Okay, and then I'm going to move left 2 up 4. So take all the points on our blue graph, again using the most recent graph, and I'm going to move them left 3 and up 4. So let's see, well, I kind of ran out of space on the graph, so I can't draw that point, but somewhere over here, left 3 up 4, so 1, 2, 3, 4, beyond the axis, it goes up to here. This one's going to move 1, 2, 3 over, and 1, 2, 3, 4 up, so my point goes from there to there-ish. Okay. This point moves left 3, 1, 2, 3, and up 4, 1, 2, 3, 4. So moving from here to here. Sorry, let me do that again. And this one moves again, left 3, 1, 2, 3, and up 4, 1, 2, 3, 4. And there you go, that's my finished graph. Label it y equals -2 g of 1/2 x plus 3 plus 4. Alright, so that is about it. That's your review on transformations. Thanks for watching, and I will see you in class.